Hello guys, welcome to the new video. In this video, we will be learning about how we can scale horizontally our WebSocket servers. So as we all know, WebSockets enable us to communicate with the server in a real time. So it opens up a bidirectional connection between client and server so they can communicate with each other in real time, and it makes your server stateful. Okay, so that's why it's a bit complicated to scale horizontally. So now let's see what will happen when we have instead of one server, when we have multiple server. As we all know, to horizontal scale we need to increase the amount of servers in our backend, right? So if we so this is a basic architecture of how you are enabling the horizontal scaling of your backend servers. So uh, you need a load balancer. Right now I am using nginx as an load balancer, and I have three servers. Okay, and I'm distributing all of these traffics to across all of the servers. But the issue here is, as we all know, when server opens up a WebSocket connection with your client, it remembers your socket ID, right? It's a persistent connection. So your server remembers that, okay, this client I am trying to communicate with, this is from this client I will be getting the message and sending the message to. So when your client makes an request to your nginx, and nginx will route it to your server, and server will send the message to the nginx, and the nginx will proxy the message to you or the client. This is fine, but let's suppose client is making another request, but instead of going to this server, now it is going to this server or this server, but it won't be able to get the messages from these two servers, because I have already explained you, uh, these are persistent connections, and these two servers, like this one and this one, don't have your don't know about the messages and don't know about your client sessions, right? Your session details for WebSockets are stored in this server, the first one, but it's not stored in this or this section, right? This is enabling another connection and another connection, so you might not be able to get your messages from this server. So how we can fix this? One way to fix this kind of issue is session stickiness. With the session stickiness, we will ensure that our client will always be routing to a specific server instead of going to all of these other servers. Let's suppose based on IP hash algorithm, your client's IP is hash to one string, and this, based on the string, you will be redirected to a server. So whenever this specific client tries again on the nginx servers and get the details, it will be always redirected to your specific server. It won't be redirected into this server or this server. So this is a one way of fixing this horizontal scaling in WebSocket. But the problem with sticky session is that one server may get bloated with all of the requests, right? As we know, client is requesting to a specific server, and it has its own constraints of its CPU and memory. So, and let's suppose multiple clients are trying to reach a server, and they are actually bloating the server with lots of requests because they are redirected to a one specific server, and the traffic is not getting distributed. So in this case, this server may end up being crashed. So we need to fix this thing, right? So we need to introduce some kind of algorithm so we can get our messages from all of these servers instead of connecting to a one server. So we can leverage the use of all of the servers across our server pool. Like here we are using only one server, but we want to use all of the three servers to distribute the load. So we can actually fix this thing with a message queue. I have written a thing called Redis adapter. I will explain you why I am calling this a Redis adapter sometime later. So what we need is a pub sub model. We can use any message queues for that. For this tutorial, I will be explaining you with a hands-on Redis pub sub adapter. So let's see how our message gets distributed to all of these servers. So first, when client is trying to make a connection to our server, first it connects to nginx, and nginx redirected into a server. and it sends a message to our nginx and we are getting this data. It's fine. But whenever server is getting a message, first what it will do, it will receive the message and it publishes the message to our Redis, which is kind of acting as in broker. And then our broker will fan out the message, or broadcast the message to all of the other servers. It receives the message from one server and it broadcasts to all other servers. Right now we can see that first server is sending the message and the Redis is broadcasting and fan out. This is a fan out architecture. Our message is sent to all of these servers. So whenever our client tries to reach to another server, they can get the message from here and here also, because now our message has been broadcasted to all of the servers in our server pool, and we can get our bidirectional messages from any server that we want. So now enough of talking. I guess we can move to our hands-on experience, how we can implement this thing on our own. This is a demo server code, and you can see that I have a pub and sub client, but I am going to explain you in a bit later. uh, So I am going to explain you this a bit later. But after this, we have our SocketIo server initialized with a enable cost. And this is a basic demo application, so I have not followed any good practices in code. It's just for showing you how things works. And also I have a client HTML, which is a basic HTML and JS. And here I am using a SocketIo client, and I'm sending the message and showing it to the UI, and you will find the code in the description below. And also I have configured my nginx. Here I am using two servers, socket server 1 and socket server 2, and I'm distributing the load in these two servers. And this nginx configuration for setting up SocketIo. And we have a Docker file. We will be containerizing our application. This is a basic Docker file to convert our code into a container. And also another, I have written a Docker compose file. So first I'm using a Redis container, and which will be inside, and every container will be inside our app network, which I have created at the down below, as you can see. And after this Redis container, I have created the server, socket server, which is a basic server, and I have configured it in a way so if I change anything on my file, it will be we will get to see that on our containers at the real time. And our socket2 server is the same as the previous one. For scaling horizontally, I'm just duplicating the servers. And here I have nginx setup. I am just changing my nginx configuration file and moving it to the actual nginx directory. And it depends on socket 1 server and socket server 2. After our socket servers are getting created, this nginx container will run. So now let's start running these containers. Okay, let's start running all these containers. I'm using docker compose up, build and a watch command, so we can get to see all of these logs in a real time. Okay, so we are done with creating our containers. As you can see, our nginx has been configured, and then socket server 1, we are getting a user is connected. So this is actually, I have opened a client HTML, so that's why it's showing that. So if we open our client.html using live server, we can see that this is our user ID 26q, and it has been connected to our socket 1 server. This has been connected to our server 1. And let's open another server in incognito mode. And now we are connected, and this is our user ID FHR. And if we check our logs here, it's connected to our socket 1 server. So both of our clients are connected to the same server. So now if we try to send our message hi, as you can see, both of the clients are getting the messages. This will work if we try to send message again. I'm sending a message again. So both of our clients are able to get the message, because both of our client requests are going to the same server. So let's open our cursor again, and let's see if we can try to connect one of our client to another server. And if we reload it, hmm. Now this user ID is connected to server 2. So as you can see, XOFW is connected. This request is going to our server 2, not the server 1. And this one is in server 1, right? So if I'm reloading it again, and so XLGJGGJ. So this user ID XLG is connected to server 1, and XOFW is connected to server 2. And now I'm trying to sending the message. Okay, so now we can see that our message is only received only at this client, but not at this client. Why? Because I have already explained you. Because this client has been connected to our server 2, but this client is connected to our server 1. So when it's trying to send the message to our server 1, it's not we are not getting the message from server 2, right? Because it don't have enough details or session details for this client. So that's why we need a Redis adapter or a broker. So he so our broker can fan out all of the messages to all of our consumers, and we can send the message to all of our across. So we can send our message to across all of these servers. So now I'm opening my cursor again, and I'm going to my server, and instead of commenting this line, I'm just restarting the server. And what I'm doing here is I'm enabling a pub client and a sub client. So what this pub client and sub client will do, this pub client will publish the message to all of his subscribers, and subscriber get all of these session details for a specific user. The user can get the message from any server that he or she wants. So as now we can see that our server has been connected successfully, and XPX is connected to our server 1. So if we minimize a bit, XPX, so XPX, okay, so XPX is not our server, so we need to, okay, so now we can see that this client NFZ is connected to our server 1, and this client EZO is connected to our server 2. Both clients are connected to a different server. Now, if we try to send a message like hello and send it, we can see that we are able to receive the message in both of the servers, right? We can see that. So that's how we can horizontally scale our WebSocket applications with with using a broker. And also we may want to monitor our Redis, so we can see what's happening behind the scenes. So if we go back to our Docker desktop and go to our Redis, uh, if I go to my exec command, as you can see, if I go to my Redis client, and I can see that my Redis client is publishing and subscribing all of this message across the nodes, so we can get data from anywhere. So at large scale, this will help. I hope you have learned something new. I would also love if you give me feedbacks of this video. I am open for suggestion. If you want, you can give me feedbacks on the comment section. And if you made this far on this video, congrats. I hope you have learned something new. Go share it with your friends.